Okay, number 45. The graph of the function f is shown to the left. Estimate if necessary. Okay, it would like us to find f of negative 1.5. So this is an x value. It wants to know what is the y value when x is negative 1.5. So it looks like, let me just make this a little bit darker here. This is the y-axis, straight down through here, and this is the x-axis. Okay, so negative 1 is here, negative 2 is here, so negative 1.5 would be there. So we go to up, and it looks like the y value is 1. Okay, so this is the opposite. This next one is saying if the y value is 1.25, then what is the x value? So let's go to 1.25. So 1 is here, 2 is here, 1.5 is here. So 1.25 is here. So what is the x value? Let's trace it over, and that looks like negative 2. All right, f of 2. So again, this is the x value. What is the y value when x is 2? So, oh no, I did that right. Y was positive 1.5. Okay, f is positive 2. So go over here to positive 2, right there, go down. Looks like it's not quite 1. It looks like probably negative 0.75. And last, if f of x is negative 1, so that's a y value, then what is x? So go to negative 1 on the y's, trace over, looks like 2.5. Okay. The table represents points on a linear function. What's f of 4? So again, if the x value is 4, what's the y value? So we're getting that right from here. If f of x is 80, so that's a y value, then what's the x? Ooh, we're going to have to do some work to find that one. We'll come back to that one in a second. F of 0. So the x value is 0. What's the y value? Look at your pattern. 8, 6, 4, 2. Go back one more. Would be 0. So because they go by 2s. 8, 6, 4, 2, 0. Okay, how is this changing? Going up by 30 every time. So go down by 30. Okay, I wanted to do this one next, or I wanted to skip over B because I just found my slope. And I'm going to write an equation to try to figure out when the y value is 80 because it's not here. Okay, so my slope is 30 over 2 because these are going up by 2. So that's my m, 30 over 2, which is 15. So what would happen if I go halfway between this? So what's 65 plus 15? That's 80. 80 plus 15, that's 95. So if 80 is halfway between 65 and 95, then my answer has to be 5 because 5 is halfway between 4 and 6. And what would give me 185? Well, let's see if we keep this pattern going. So if I add another 30, that would be 155, and that would be 10. And if I add another 30, that would be 185, so that would be 12. Okay, big long word problem. Let's see what our keywords are. They charge based on miles. There's our function. They're charging, so they're adding money to your bill. Which statement's not true? Okay, well, first thing is this is kind of in y equals mx plus b, but not quite because we would want the mx, what did I just do? Plus b. So that might help us a little bit. Slope of the line is 1.5, represents the cost for each additional mile. Okay, let's see. So 1.5 is definitely the slope. Oh, this is not true. Okay. Delivery cost, that is m miles. Okay, yeah, that's definitely true. Okay, the graph includes the point 2560, which represents 25 miles is $60. Okay, so if we plug in 25, 1.5 times 25 plus 22.5. Okay, what does that equal? I want to know, does that equal 60? Let's see. Go with my calculator. 1.5 times 25 plus 22.50. Oh, 60. Okay. That works. Okay, y-intercept of the line is 0.2250 and represents the cost with no additional miles. Yes, that will be true. That's our y-intercept. And the x-intercept is negative 15.0. It represents a refund if no miles are driven. Yeah, that's definitely not true. You're not going to get a refund. Okay.
Thanks, Rochelle.
You're welcome. Okay, the scatter plot shows the number of cups of coffee consumed by an individual. Okay. Scatter plot. We need to put this into our calculator and make a scatter plot. Okay, oops. So, home screen, new document, don't save, add your lists and spreadsheets. This needs to be X, this needs to be Y, oops, only one time. Don't put anything here. And now I'm going to start typing in my data. Okay, so my first data points are 1, 6 and 1, 7. What the heck just happened? I'm going to start over. X, Y, 1. Why is it doing that? What in the world? 1, 6, 1, 7. Okay. Ooh. Okay. Then we have 2, 5. Then we have 3, 8, 4, 4, and 4, 6. 3, 8, 4, 4, and 4, 6. And then we have 5, 6, and 5.5, 4. Then 7, 2, and 7, 4. These actually don't matter what order they go in, because when we go to the next screen, it's going to line them all up for us. So we go to document, insert, and we're going to insert data and statistics. X is going to go across the x-axis horizontally, and Y is going to be vertically along this y-axis. And then we see scatter plot just like we had. Menu, analyze, regression, and then show linear. Oh, didn't like something that I did. Oh, didn't press enter on the last one. Okay, menu, analyze, regression, show linear. Negative 0.55 plus 7.37. All right. Looks like trash cans in the way. Looks like A is the best answer. Okay, let's try to graph these and just like on here and kind of just see why. Okay, so I have a y-intercept of 7.4, so I would say that's about there. And my slope is negative 0.6, which is 6/10. So that means from this y-intercept that I just made, I'm going to go down 6 over 10. So 1, 2, 3, 4, 5, 6, and over 10.